Hi, good morning, everybody. Hope you're all well. So I'd just like to welcome you to this webinar today for Become 75% Faster in Your APQP PPAP process. So my name's Russell Persglove. I head up the software division here at Sempra. And again, what I do want to just get across is, should anybody have any questions, feel free to pose those in the chat, and we'll answer those probably 10 minutes towards the end of the session. So yeah, if you have any questions, feel free to just keep pinging them along, and we'll get to those right at the end of the session. The session will be recorded as well, so we will get that over to everybody shortly after the session's ended. So should anybody have to leave early, again, that's absolutely fine. We'll send them the recording. So what I'd like to do is really just really invite you to this session to understand where we are as Sempra, and we're the UK sole reseller for the HighQA software, and today is really to understand how within businesses, the APQP process is very laborious, very time consuming. We've got to be faster, we've got to be efficient. And what PQP stands for is a production quality planning. It's an application that HighQA have recently introduced, and it will enable businesses to be more efficient, save time, and be more structured in their process. So typically engineers use Excel as a driver, and again, we need to get away from that. So the software will allow you to do that dynamically and manage all of the APQP process, so FMEA, control plans, all of that kind of good stuff that we do today, which is, again, very time consuming. So what I wanted to do really is to introduce now HighQA, because it's a new application. We're going to get the team at HighQA to introduce and walk you through a presentation of how it can enable businesses to be smarter and more efficient. So I'd like to introduce you to Tim Hogan, who is the VP of Business Development for HighQA. So hopefully you should see the handsome young man that he is on screen, and he'll walk you through the demonstration. But like I say, any questions, feel free to ask them on the chat, and we'll cover them towards the end. Hopefully you enjoy it, and yeah, look forward to your feedback later. So over to you, Tim. Thank you.
Well, excellent. Well, thank you very much for that. Greatly appreciate it. Thank you for everyone for joining us today too. We appreciate you taking the time, because your time is very valuable, and we're certainly want to be cognizant of that and not waste it. So we're going to jump right into the message and explain how to save 75% of your time by automating your submission requirement packages. Now, we're going to present a slightly different format today. Typically, we would run through a PowerPoint presentation explaining the process and how we can help fix the bottlenecks in your system. However, today we're going to take a step back and just introduce the concept of what we're going to be addressing. And then we're going to spend the vast majority of our time with a live presentation of the software itself and our PQP application. So we hope you don't mind, but we thought you might like to see the product in action and how it can actually streamline your process. Now, is 75% a realistic number, or is that just puffery? We typically state as a company that you can save at least 50% of your time. However, our customers do tend to tell a different story. It's not uncommon at all for our customers to see a 75% time savings from their existing process, how they're doing it today. Okay, so we all get acronymed to death in manufacturing, we know that. However, it's important to note that although there are different forms of terminology across industries, many of the requirements are actually the same. A PFMEA is a PFMEA, whether it's part of a device master record or an AS 9100 package. So whether you're in medical or aerospace or automotive, construction, or even defense, most industries have adopted some form of quality system to address some, if not all, of the original 18 elements. But why do our customers need help? So, well, why do people go in business in the first place? Most people go into business to help other people, right? Make a better life for themselves and hopefully turn a profit for investors. They typically do these things by growing their business. And if something is limiting that growth, It also limits the amount of impact they can have on others. What we hear frequently that shop owners or plant managers tell us goes something like this. Look, I can add machines. I can add production. I can add capacity. I can even buy robots to load the machines so I don't need as many people on the shop floor. But where I'm struggling is finding people and resources to complete all the documentation needed for PPAP submissions. And quite honestly, they're stuck in a quandary. If they add more people to do paperwork, this typically adds to the overhead cost and makes the piece price go up to where they may or may not be awarded the job. But if they don't add the people, they run the risk of not shipping in time and therefore potentially losing business or future business because of missed shipments. But why is so much focus and emphasis been placed on streamlining the manufacturing process and making parts better and faster with more robotics and automation and process control, while very little has been applied to the quality documentation side? What if we could automate the documentation portion of a PPAP submission? That's where we come in with HighQA's PQP application. As Russ was alluding to, and pardon the play on acronyms, but PQP stands for Production Quality Planning. And no matter the industry or sector, if you're producing a part, you need to prove that the parts you make and the process you made them in meet certain criteria, and you need to document it. So from a 2D print all the way through manufacturing and submission, we can help control your quality process digitally. That's right, this is not a file management system. This is a database-driven solution that provides complete transparency of part records, and it also increases the collaboration between departments, especially manufacturing and quality. Now, I promised to be short and not kill you with a PowerPoint, so I hope I did just that. So let's delve into the software now and show you how the PQP module works. So here we are with a print pulled up here, and this is HighQA solution called Inspection Manager. And what we're going to do, we're actually going to open a new drawing. We can use 3D models with embedded GD and T in it as well, or PMI data or MBD, what have you. But wanted to show you that still most of the parts that come from our OEMs, or at least when they're passed down the chain, they are a two-dimensional print. And that's where a lot of our customers have the need. So, and oh, by the way, when to lay a foundation a little bit of how this is going to work, the PQP portion is a little bit toward the later end of the full process. So we wanted to show you how we can build into that process. So just bear with me for a little bit, because what you're going to see are some foundational elements that are needed and required in order to build some of that PQP information, control plans, PFEMAs, what have you. Okay, so I wanted to kind of lay that out there. But the foundational element is usually a balloon print for us. You know, customers will get an order in, and it'll typically have a two-dimensional print and a purchase order with quantities and any other delivery requirements as noted. So when they do, that's kind of the starting point. But a 2D print is really a dead file, right? It needs to be redigitized. And a lot of people do this by ballooning the print, sometimes manually, sometimes using some type of automated device, and then populating it into probably like an Excel spreadsheet. And then that Excel spreadsheet is saved on a network file folder somewhere. And it's still kind of a dead file. It's not live. It's not shareable in the sense that other people can collaborate on it. It's just a file saved in a folder somewhere. So we're going to kind of redigitize this and bring it back to life, if you will, from the CAD state. So we have a OCR, what we call optical character recognition, and we're just going to come up here and say single, and excuse me, auto balloon this, and we're going to use single page. We have options here of you can turn them on or off, use them or not, completely up to you. Multiple pages, basic dimensions, reference dimensions. Some customers want them, some customers don't. It's completely up to you. We're just going to come down here and hit OK. Now, once we do that, it kicks in the OCR. This is a proprietary OCR. We designed it to look specifically for dimensions, for GD&T, and to automatically extract that information and put it into what we call a bill of characteristics. Now, that didn't take very long at all, and you can see that the print is completely ballooned. Let me zoom in on a little bit so you can see some of it here. Fully ballooned and annotated, but more importantly, I mean, let's face it, you can put balloon numbers on a print moderately quickly, but how fast can you get that information out and into some type of either spreadsheet or database form? And that has already been done in those first few seconds that it took to balloon the print. Everything from the dimension number to the drawing zone, the type of feature it is, the requirement itself. We even identify if there's a multiplier and note that in the database itself. So everything you're seeing right here is already in the database. It doesn't have to be like saved into the database. It's already there. All the tolerances associated with it, whether it's a general tolerance from the title block or whether it was notated on the print itself, it'll also distinguish between those two factors and populate the database accordingly. And then also a sampling rule, which we'll get into in a little bit, was applied. So all that information is automatically put into the database right in those first few seconds that you saw. Additionally, we have this pretty outstanding OCR. We can extract more information from the print by using it. So how do we do that? Well, if we go over here to our part properties, that's more of the document information as opposed to individual dimensional callouts. We can see here, you know, what the sample part name is. We can go up here into this little button called Extract Title Block Text. And when we do that, we're simply gonna, just like you're clipping a picture on your computer, it's just a box select. And as soon as we let off, we get a box that says, okay, what is this? And we just say, oh, this is the part name. And now we can see our part name has been updated to whatever was on the print. Similarly, we can grab the part number and we can see the part number is identified there. And we can even toggle between alphanumeric. You can see that it's Rev A right now. And if we say this is the part revision, you can see that that's changed to 003. So we can grab all of this information. I haven't touched the keyboard yet. This is all done using the OCR. So another feature we have that a lot of our customers find very, very helpful is a function called whiteout. So if we click on whiteout balloons, what that does is it actually whites out what it did get, so you can easily see what it didn't get. And you can see just by looking here, it did a pretty good job. It got most of the dimensions. And that's what we find typically with what we call a clean print. If you have a print that's been scanned several times and the resolution isn't good, it may struggle a little bit. And if it does struggle, we could just manually clip those balloons. For example, if it would have deleted this, I'll delete this one to mimic it missing it. We would come up here into balloon dimensions, and then we can simply do the same thing we did with the title block. We're going to box select it. And as soon as I let go, it's reparsing that information right over here, what we call parsing. And when it does, it's figuring out what it is, how many decimal places, what the nominal is there a tolerance associated? If not, apply the general tolerance. And the kind of preview for it is right up here. So it grabbed all that information. And now if we click off, it's hidden again. We can also balloon notes as well. Right under our clipping function here, we have balloon note. And if we do that, similar to what we did in the title block, we're just going to box select it here. It's going to automatically parse that information and put it right into the notes section of the side over here of the dimension editor. And it's, again, automatically in the database. You can see it right down here. It's not quite spaced equally, but you can grab additional ones as well. Let's grab both of these. Now, once we do that, they disappear. Now they're ballooned. As kind of a side note, in a little bit, we're going to talk about getting data back into Inspection Manager and then what to do with it. So when a note is in the database, it's going to be looking for a pass or fail. So the just note that, pardon the pun, but note that the data that it's going to be looking for is a pass-fail in that respect. You can change that if you need to, but for the most part, it's just a pass-fail. And if we click off of that, we can see everything is done, and we can turn off our whiteout and see all of our dimensions. Now we can also see that they're significantly out of place, right? Because we always put it on the end, what we call n plus 1. So it's the end spot and then the next feature past that. So that's where these lined up, because we don't always know if it's a revision, engineering change, or something along those lines to where it needs to be kept separately and added to the end, or if we want to include it. In this case, we just want to include it. We do have a renumbering option right at the top here. We just hit the renumber button, puts everything back in line. Some of our customers want to keep the notes first, and also note that you can simply click on the number itself, renumber them. Whoops, it automatically goes to the next one. So it's 1 and 2 now. I just manually did that, and you can see that the old number 1 and number 2 are now 45 and 46. Now I'm going to come down here into the bill of characteristics. I'm going to do what's called lock dimensions. So if you have a number that's in the system and you want it kept in as that number, we can simply lock those. And now when we renumber it, it comes up with a note that says you have locked dimensions. We just simply say, okay, and then it keeps those. And now you can see this is 3 and 4, and it starts there. So it starts the process over again. So just wanted to show you that. I don't know if any one of you get some crazy prints that are in inches instead of metric. If that's the case, as in this print, if that is the case, we can simply come up here to our convert option, and it does convert it into the other unit of whatever is there. So that's sometimes a convenient option if you get the wrong scale prints, if you'd like. Also, one aspect that we can talk about very briefly are gauge categories and characteristic designators. That is simply a way for us. I won't get into it because it gets into a little bit more of the software, but the gauge category, what we're doing is we're setting up a dimension for later on downstream. If I wanted to select this, hey, I want this measured with a micrometer, and it's a key characteristic, something along those lines. We can signify those things, apply different rules to those features if they're significant or if they're not. Another element we do want to touch on, because this helps tie everything together. Again, we're laying some foundation work because having the gauges associated with the dimensions that we're going to check, now we have gauge information along with the engineering information from the print, right? And then we're also going to have the data, and then we're going to build that into an FAI. That FAI is part of our submission package for our PPAP. So the gauge information can be automatically populated into the FAI that goes into the submission package. All of this information is correlated, so that's why I wanted to at least unpack it and show it to you a little bit. Because this has a full gauge management package in it. Just grab one here and explain it very briefly. Has the basic information that you'd expect, right? Location details, a gauge information, calibration details, last calibration date, certification number, things of that nature. We also have notifications set up to where you can notify people if it expires or if it's expiring soon, and you can set that time frame too. We can import everything you already have. If you have it in Excel or using a different gauge package, we can also synchronize with an existing package if you'd like to keep the one you have. But the one thing that we do that we don't believe anybody else does, we haven't found anyone yet, is if I pick this thread gauge, for example, we have this little button down here called usage history. And if I select that, what you actually see here is every dimension that that gauge ever checked, down to the job number, the lot number, the serial number of the part, the dimension number of the print, what the requirement was. If I scroll over to the right here, I even know who measured it, the date, timestamp. We can tie it back to a machine if it's tied to a non-conformance report as well. And of course, if it's good or bad, right? This will show good or bad here. So all of that information is captured and in the database. So we don't have to go back, and if we have a bad gauge, maybe a drop gauge or something, a lot of times we need to go back and find out where it went bad. And thumbing through reports and files and of that nature. Now we can simply come back and say, oh, it's right there. It started checking bad right there. So wanted to go over that because we're going to get into manufacturing operations next. So in manufacturing operations, this is really one of the key components. When we start to unpack PQP in a few minutes, it's really going to come down to manufacturing operations and how that's built. So let's identify that, because manufacturing operations in the software is one of the first steps into which we really start to integrate in between or interdepartment, if you will. We increase the collaboration interdepartmentally because this is typically a manufacturing role, right? A manufacturing engineer would take this print, break it down into operations, identify the dimensions that are going to be checked in those operations, create a print for that specific operation, which only has those dimensions highlighted, that nature. So we can actually do that here. And again, we're using the same information. Let me show you what that means instead of me just talking about it. So when we get into manufacturing operations in the software, we can see we always have a finished part, right? We're always going to need to check those dimensions sometime in the finished state to be able to put onto our first article report. But we could also have dimensions, I'll just select this view, for example, that maybe all of those are cut in one operation. So we could simply select the dimensions we want and click on Add Operation over here to the right. And we can see immediately we have multiple colors here to identify that those dimensions are being affected by multiple operations. Additionally, we can come over here and click on our little pencil, and now we can add additional information. Maybe this is a roughing up, for example. We can even tie it to a specific work cell if we need to. We can put it on a specific machine. Hey, this is being done on our lathe, for example. We can tie it to a specific process. Now, this is the key factor that we're going to come back to in just a couple minutes of the PQP side of it, because as most people here know, probably know, or at least all the quality people here, all of our documentation and information is built around a process, right? What is the process? And then what are, the failure modes of that process, or what's the flow of that process? So everything's built around a process. We're going to come back to that. But now we have our roughing operation here. But more importantly, right down in our bill of characteristics, we have a manufacturing operation pull down. We can just select the roughing operation. And now I have a print of just my Op10, just that roughing operation itself. By the way, I had a note, or I had a rule based in the system to where if it's a key characteristic, change the symbol to a triangle instead of a circle. That's why you're seeing a triangle on the print. So in case you're wondering why there's a triangle up there. And you can see right down here that key characteristic that I identified. So we have our operation 10. But if it's a roughing op, we're going to need to leave some material. So a lot of manufacturing engineers, what they do is they go in and modify the nominals in some fashion, right? They could change a sheet, an Excel spreadsheet, something on the floor. We've had customers say that they just write it on the print. But you can do that right inside of Inspection Manager. Right here, we can select nominal value. I'm right down here. You can add, this is an inch print. Let's say I want to add 20 thousandths of an inch. We can add or subtract. You can go by percentage, value, whatever you really want to do. This is mostly IDs, so we'll just say we're going to subtract them. And maybe we want to say our plus or minus 10 thousandths of an inch as a set value for the specification itself, because it's a in-process check. We can even say, hey, what do we want to use to measure these with? Oh, we're going to use that blade micrometer. If we hit apply and close, now when we come down to our bill of characteristics, we can see that the dimensions have been changed, right? This is 425 and 425, and we see on the print it was 445. So it's been changed that 20 thousandths of an inch to make up for the material we want to leave. So that's all captured right in the database and in its own specific operation. So that's very critical for the next element, because we can simply come up here and say, I want to build an inspection report from that. Some people call them like an in-process check sheet. Some people call them inspection plans. You can actually have your own template here. If you have your own template at your company, excuse me, you can use your own. We can simply hit create report. Oops, went on my wrong screen here. Let me pull it over here. It created it in Microsoft Excel. You can see that the operation number, this is only for Op10. This is our in-process check. Our requirement is the modified requirement from the 20 thousandths that we took off of it. And there's our nominal value with the set amount of 10 thousandths that we wanted for the tolerance, even the measurement tool. And now we can take this information, if we wanted to, and simply fill it out. You could do this on the floor. You could have the operator do it on the floor and just fill out this information here. And then what we can do from a software standpoint is take this Excel spreadsheet and bring it right back into Inspection Manager. Now we're going to start talking about bringing data back in, and that's one of the ways we can. We can simply bring this Excel sheet right back in. However, it's not the most efficient way, because it's a multi-step process, right? I have to build the operation, which you have to do either way, but then you need to build the in-process check sheet, have someone fill out the in-process, this sheet, and then bring that filled out electronically, and then another step of bringing it back into the software. Another option that we have is a shop floor data acquisition tool called IM Explorer. Now in IM Explorer, you can tell it's a little bit more of a simplistic system, and that's exactly how it was designed. It's designed for the shop floor to be able to put in information that's being measured on the shop floor and it being accessed directly into the database. But they don't necessarily, need to have all the information from the Inspection Manager package, but B, you don't want them to have exposure to a lot of things that could potentially go wrong, or could be inadvertently pressed, or what have you, the wrong button pressed, if you will, to where it would provide some like erroneous data inside the system itself. And we do have the gauge package that you saw before is integrated into this, right? So everything is captured inside of here. You could check gauges in, check gauges out, use it as your inventory-based system. And again, it's all linked to that same database, so you're working from the same data. You're not having to populate it back and forth. However, when we're talking about just getting data into the database, we can simply click on our gallery view here, and it's more of a picture-based, hey, what part am I working on? What am I looking at here? And if we can also go into like a job number, for example, if we know what job number we want, oh, there's our part for that specific job number. When we go into that part itself, or excuse me, into that job, we have some job information by a nice dashboard that shows inspection completed, if there's any failed dimensions in it. And then once we go into the job, we can see we have a sample 001 ready for measurement. And if we go into that sample, now we have the ability to enter information in directly from the shop floor. Now, some people will also use this, like in a QC lab, if you have an inspector doing manual measurements, but that's all they do is manual measurements, because you can actually enter information in Inspection Manager too. But you can also, one thing I wanted to point out is you have the option for manufacturing operations up here. So now we can enter in information just for that manufacturing operation. And right over here on the side, I hit control on my keyboard. That's why control came up, because it's listening. If you happen to have any wireless gauges or anything, you can have it automatically populate right into the report. And let's say I measure this and it's 0.5. 0.5 is out of spec. So we automatically get a message that pops up that says, hey, wait a minute, this is out of specification. What would you like to do? Would you like to measure it again or adjust the value? Just for the sake of time, I'm going to say keep failed. Let's say it really is bad. It'll automatically pop up with a non-conformance record for them to fill out right on the floor. And they can simply say add new. And again, the power of the database comes into play here as well. I have all the information already. I have the job number, the who's doing this because I'm logged in. And it says, okay, what's my creation date, even a specific non-conformance number. All we need to do is say what's happening and say, well, we need to repair this part. Maybe it was dented. And you can tie it to an inspection center or a machine if you'd like. We can just say, okay. And now we even have a defect code, and this code is completely configurable to match whatever you need it to be. Some will make sense, some won't. And maybe this is like a machining defect code, and we can say, okay. And now that non-conformance is in the system and logged in the system. We also have notification settings set up to where if a non-conformance report is created, notify people. If it's modified, notify people, changed. So we have notification settings available as well. But now that information is all captured in here. And if it is captured in the right way, meaning a good dimension, you can also, oops, I'm the wrong one. My apologies for that. Helps if I grab the right one here. Nope. Oh, that's right, because I just tolerances. That's funny. I was actually putting in the print specification. And this is the adjusted one that we adjusted right into the in the manufacturing operation. So that's kind of funny. Now, if it is correct and it's a good measurement, I just wanted to point out here as well that you can see it right on the print. It shows green, goes to the automatically toggles to the next one. And if it is bad, it'll show red and then toggle to the next one. So you get a good visual of the part right straight away. Also, we get a lot of customers asking about work instructions. Also note right down here, you can have a different tab for work instruction as well. But we want to get into PQP as quickly as possible. So what we'd like to do now is kind of roll that over into the PQP portion of it. I'm going to open up the same part, but it has the PQP documentation populated. For the sake of time, we don't have time to build everything up right now. So we're going to go right back into manufacturing operations. One aspect I didn't touch on, we have a third way to bring information into the database, and that's from, like, if you have a CMM or some type of, an ARM, a tracker, a VMM, some type of automated measurement system that runs on a software. Well, that software can export a file, usually a CSV or some type of delimited file, to where we can automatically bring that in. So what'll happen is once that saves out to a file, we can listen for that file location and automatically bring it in and automatically populate right into the database. So everything that you've seen so far is the manual entry. We also have a completely automated entry for any type of automated measurement device. But going into the PQP side of the world, now we're getting back into manufacturing operations. Excuse me. So we have our manufacturing operation set up over on the side over here. And we can see that we have drilling, turning, milling, what have you, but also the process ID is identified. Let's go into one of these so you can see what I mean. So this was our same exact screen we were in before, but this has a process in it now. We identified the process as our turning process. So when we do that, and ultimately this is what we need to do, or what you will need to do, to define those processes, because everything, as I mentioned before, is linked to that process. Okay, all the documentation, everything. So when we get to this point, now we simply come over here to our PQP records, and everything that we've identified has been automatically updated into all of our documentation here. For example, and this is our submission package. Here's our process flow, for example. Our process flow diagram. Here's the turning, for example, that we had before. It's right here in the process. It's a fabrication step. Now I'm going to kind of show you the end result right now. This is how it works. And then in a few minutes, I'm going to back up and show you kind of how we got there. Because what you'll hear quite a bit when we start talking about this is templates, or being templatized. What that simply means is all your data is housed in a repository, and we are going to pull from that repository whenever possible. Now that repository is right here in Inspection Manager, and I want to show that to you in just a few minutes. It's part of the PQP process. So all this information has been captured and it's in here. We can go back to our index. This entire list is what we define as an index inside of the software. So we can go into our PFMEA, for example. Here is all of our PFMEA information for all of our processes as we've identified those. You may have noticed in the process flow diagram, I forgot to mention something, I apologize. You can add additional processes to the process flow. In fact, let me show you real quick. It won't take but a minute, and I'll pop back to this one. So in the process flow, we're going to have processes that aren't necessarily a manufacturing operation, right? You're going to have, ordering material, for example, would be a great example. You may or may not have to inspect anything. When you're packaging, when you're shipping, you may not need to do anything. So you can add processes in addition to whatever is in the manufacturing operation list. So did want to point that out, because when we go back to our process FEMA, what we've noticed is that all of this is tied to the process flow. Okay, so the process flow in our system is the first step. So the manufacturing operations are going to tie to the process flow diagram. The process flow diagram is going to synchronize the rest of the documentation. Okay, for example, we have sync processes right here. If we had a change to the PFMEA, I'm so sorry. If we had a change to the process flow diagram, it would show up with a note here that says, hey, you need to sync your processes. And you'd click the button and they would all be synchronized. So we can see our milling operation is here, our received material. Now this is a PFMEA that you're probably used to seeing, but you're used to seeing it in Excel and all the cut and paste and slice and modify the columns correctly so it looks nice, all that good stuff. But all of the base information is here, right? The potential failure effects, the severity, the causes, the prevention, again, detection, all of this is automatically done. So what we're going to see in a couple of minutes, again, is where it came from. But it's important to understand that that's what we call the template. Important to understand that when we pull it from the template and it's now in this individual part record, it's saved, let's call it saved locally. Think of it like that, because it is now part of this specific part record, this specific part number even. And not part of that template. So we can change things in here. Maybe if the customer doesn't want this as a 4, they want it as a 10 or a 9. All of the information can be put in here, and now that 9 has kicked up the RPN. This is all automated. So as soon as you change something, it's automated downstream and automatically calculated. So that's all tracked as well. You can also modify things here, put in here anything you want. But again, when we're doing it here, we're doing it more on the local level, on the part level, not on the template level. So all the information is captured here. Let's go back to our index. We even have our control plan. We can see our control plan has all of our information, all of our processes, all of our print numbers as identified in those processes. This automatically was populated from the manufacturing operation, right? Because we identified those dimensions in the manufacturing operation, and then we updated the process flow, and then it came in here. And now those dimension numbers from the original balloon print that went into the manufacturing operations is now automatically generated and populated into our control plan. We don't have to copy paste. We don't have to make sure everything's there. Now, one question we get a lot of is the index itself. So many customers on this call, or prospects, or people on this call right now will look at this and say, well, that's fine, but I have this customer and this customer and this customer, and they all have different requirements. They all have different everything, different forms. How can I change that? Can I make that specific to them? And the answer is yes, you simply can. We can come up here and say right up here, if you didn't see where I was, and say change index. So I have a few different, and these are just fictitiously named, they're not specific. If we have a 9145 that we're doing, and we say preview, these are all of the documents that we need inside of our submission package that's titled AS9145. Now this can also be customer specific. Maybe we have Airbus or something like that, right? So you have Airbus level 3 or Airbus 9145, something along those lines. You could have, Volkswagen level 5, whatever you wanted to have, and they would have a specific amount of documents in them to be able to generate and populate. So all of that information is captured in here and able to be modified or changed almost on the fly, you could say. So we'll close that. Did want to bring up a couple other things. We're still doing good on time. We can build final packages. So the idea is to get all of this information and then build that final package, right? And submit it to the customer. All of this information is tracked electronically. For example, if I go into, and all of the forms are too, if I go back into like the gauge R&R, for example. So you'll also notice that some areas of this form are yellow and others are not. And by the way, this form is completely configurable. This is customized. It's just like a cut and paste form that you designed. We actually do it in a form designer. So this would be exactly how you want it to look. The right colors, the right logos, everything. But everything you see in yellow can be modified. And by the way, on the form itself, obviously there's, we can have pull down menus with certain things. We have a calendar little mini application. But once we have information, there's no information here. Once we do, it completely creates all of our gauge R&R information here. And most importantly, we can send this. See this little button right here says send by email. We could email this to our customer. Let's say we had it's a challenging tolerance and we ran a 12 or a 15% R&R and we need to get signed off from the customer. We can actually send this to your customer, have them sign it digitally and send it back to you. That is retained right in the document package that you need to retain for your submission. And by the way, you can also, for the submission level, you can identify if you do need to retain it, submit it, whatever, or it's not not applicable. So let's get into where those templates are and where some of this information comes from. We're going to go up to our manufacturing tab up here. There we go. The two elements we're going to talk about right now are the process library and the FMEA templates. So in the process library itself, it's just what it says. It's the library of all of the processes that we identified. So when we had that pull down list in manufacturing operations, this is the list that it was showing right there, okay? So we have all of our processes listed here, and here's our milling process and the turning process, for example. Let's now look down on the lower part here. This is the template to where all of that information got pulled from, right? When we saw the process flow diagram, it was a fabrication step. That's because we have it identified as a fabrication step here. So this is where it pulled that information. The other elements in it, I don't know if you noticed, they were kind of blank. Well, that's because we don't have any other information listed here. Otherwise, that would have come over as well. We have our template FEMA here, and this is based on, or not based on, excuse me. This is the template to where the information was pulled from. Now, please keep in mind, we are at the what we call system level. We're not at the part level. So if we change anything here, we're changing the entire system. Want to stop here to also, well, actually, I'll bring this up in just a minute. Sorry, I'm probably the wrong spot, but just wanted to let you know, you can even type things in here, change things, modify things, but now you're doing it at the template level, right? I don't want this as a 4, I want it as a 2. Okay, great. Now this has all been adjusted, recalculated, but now you're at the template level. So now any future time you pull this in, it'll have this adjustment to it. So everything is live and changed as you go. So when we look at our PFMEA templates, and we'll just slide this over here so you can see a little bit better. This compiles all of them together, right? By process, here are all the process names over on the side, and here's all of our template information that's being pulled in. Now, here I'd like to just take a stop for a second and maybe paint the picture for something else. So where does this all go? So we have the balloon information, we have data that's being acquired and compiled in the database, we have FAIs that we can automatically generate, we have PQP information that we can, or documentation that we can automatically generate. What's the next step? Where does this go? The next step naturally is actually supply chain. So imagine having all this information and packaging it and now sending it down to your suppliers. Very powerful if you have multiple suppliers doing the same part. We have a lot of customers that say, you know, they get information back from different suppliers and all of that information is different. It's a different balloon number, it's a different format, you know, different failure modes, which could be true, right? Because it's unique to that that unique supplier, maybe they have different equipment. However, if you had this packaged and sent down to your supplier, you can get it back in your same format now, and it'll actually populate right into your database. So that's what's very important and why we try to templatize things. Because when it's templatized, now if everything's the same and all your nomenclature is the same, or verbiage, when it populates back into your database from your supplier, it just flows right in. It doesn't have to be modified or checked, or, you know, you don't need a matrix to try to, you know, make sure everything makes sense. Everything is consistent, and consistency is really the key. So all the information is captured here in our template. Also wanted to bring up one other point, that a lot of customers, when they see this, they do, at least in the demonstration process, they start to get a little freaked out. And the reason they get a little freaked out is because they say, or they think that, oh my goodness, I need to enter all of this information in here. And actually you do not. You don't need to enter your information, and we give you full templates that are pre-populated. It does not get you fully there. What our customers that have implemented this tell us is that it gets you about 85% of the way there. They said there's about 15% left that's that they need to customize. So please don't think you need to enter all this information yourself. In addition to getting the templates from HighQA, you also have this import function right here that shows you, or that you're able to import your PFMEA templates that you have in order to get your data in here and templatized. Okay, so please know that you don't have to do this all manually. Did want to bring up one other thing though that's pretty important. I know we're starting to run a little short on time. In our settings, and again, we're still at the system level, wanted to talk about component templates. This is where you would actually build all of the information. Okay, for example, for the indices, we can look at our level 1 PPAP and see what it is right here. You saw it before when we were changing the index. Right here is where you'd actually go in and modify that index. Okay. Just wanted to show that to you, but what I wanted to talk about was actually workflows, because workflows are very, very important. Now, workflows, think of it as two different ways. We have the submission level workflow and also like a document level workflow. But we can actually expand it past that, but we'll start there. If we have PQP workflows, for example, what does that look like? Oh, well, this is our workflow for a local PQP that needs a signature, right? So we have a start, we have a draft, we have a review, we have a sign, and we identify all of these steps and who's responsible at this step. Because I don't know if we'll get into this, but from the administrator level, like the IT level, we can identify people into certain roles. So if you are a QC manager, for example, great. When this hits the QC manager spot that needs a review, it will go to whoever's listed in that role. Okay. So also you can have any type of workflow you want. Important here is that we can actually go external as well. It's not just an internal approval system, it can be external. Example, this is going to customer for customer review, signed, and then sent back. So we have that workflow as well. We do have just standard ones for basic documents. If you have, this is not PQP related because we need traceability, right? Everything needs to be traceable and be able to be tracked in the system. Everything that's being done in HighQA is logged, tracked, time, date stamp, everything is logged and tracked. So everything is fully traceable. And one very important note I didn't mention before, when we were talking about the database, being more a database driven solution, typically this is a database that's installed at your facility. I say typically because that's how a lot of our customers want their data secured in their network. We do have a cloud option where you can put it on the cloud. However, a lot of our customers prefer not to have the cloud, even though it is pretty secure, or it is secure. But this is typically all inside your system. Even the shop floor data tool that you saw called Explorer, that was routed to an IP address that would be inside your facility, inside your network. Okay, so all of that is captured within your network. And so all of these documents and all these workflows are also within your network. And we have notification tools, to notify you if something's late, if something needs to be signed, there's a requirement that's missing. We have a lot of notifications from that respect as well. So I was going to show you one other thing, but we're running short on time. So we will probably stop there and turn it over to questions right now.
Okay, great. Thank you so much, Tim.
Yeah, thanks, Tim. That was very informative. Great presentation. Thanks for that.
My pleasure.
Let's take a look at the questions. We did have a couple come in. And just a reminder to the audience, you can go ahead and type in your chat to ask any questions that come to mind. So the first question says, what functionality in the software do your customers see the quickest ROI?
Let me answer that in two different ways, because it's a two-step process, a two-step answer. And one is the quickest ROI and one's the biggest ROI. So the customers that have implemented our software usually right out of the gate see the most benefit from the ballooning and inspection planning. that's the fastest, because as you saw, it took like 15 seconds to balloon this print and extract all that information. That is one of the fastest ways you can get any type of ROI. The largest ROI that we see is when they start to get that data back in and then roll that into the PQP module as well. So the PQP module is different because that's for your submission packages, right? First off, but the data submission, or excuse me, the data acquisition, that could happen ongoing, even after submission, right? Regular production. So the largest ROIs, when you start getting that information and getting it back into Inspection Manager, because we can not only create reports, which you saw, we could track SPC ongoing. We have an SPC module that both on the shop floor and from the engineering side has full functionality for run charts and your CP, CPK, any of your capability information. So that's where people get the biggest ROIs, when you start getting data back into the database. So the quickest ROI and the largest ROI. But then the PQP from the submission side, that's almost exponential as well. It's hard to quantify which one's better, because it depends where you're in your organization, where you are seeing the biggest challenge with timing.
Okay, great.
We do have another question as well, Tim, and it's from Mark Green. So on the FMEA severity, does the system automatically select the highest value from a selection? So that's on the FMEA severity. Does the system automatically select the highest value from a section?
Let's take a look. So does it automatically select the largest one here? I'm assuming you mean if it's the largest here, does it automatically select that? It doesn't necessarily automatically select anything. You can see here that the row itself has been expanded so that 8 encompasses all of those. And each one is individually calculated. So it's not necessarily automatically select anything. It's going to select whatever you have in the template, whatever is in the template, and then pull it over.
Thank you.
Hope that answers.
Yeah, no, that's fine. Can I connect to our MRP database to share data? So yeah, basically with HighQA being a SQL database application, it can integrate with any ERP, MRP or PLM system.
Mm-hmm.
So yeah, that's it does require an open API within the application, but it's definitely something that we can manage.
Absolutely. Just to further expound on that, we do have an open API. So if there's any other software you have, could be a PLM, could be an ERP, anything like that, that has an open API, we can bidirectionally share information with those software systems. Absolutely.
And then there's a couple of questions on costings. What I'll do is we'll touch base with those individually, and then we can obviously share and understand what it is, because it's modular in essence. So what we can do is configure it to what your requirements are, so we can meet your objectives and deliver the right package for you. So what I'd like to do is obviously touch base with those in person, and yeah, we can have a discussion and provide the relevant quote that's applicable to you as a business, if that's okay.
Mm-hmm.
Okay, I can't see any more questions. Have you any more questions, Lisa, at all?
Yes, actually, here's another one. Is it possible to start small and grow into the full functionality, or is it easy to add additional modules?
Yes, actually, it very much is. You can grow with it. There is kind of what I'll call a base level of product, if you will. We don't completely modularize everything where it seems like, oh, I need that. Oh, I need that. So there is a base level of product. And then do you need to have the automatic data import from a CMM? Do you need to have SPC? Those are modules on top of it. So, and then the PQP is actually it's an application, an additional application that works right inside of the software. So there are some different aspects that you can add to it, but also note that you can start at a certain level and then grow into it as time allows. So yes, definitely.
Okay, so obviously conscious of time, we've just got one more question that we can cover, and that's basically it's saying we use a competitor software and can we get the drawings from that software? So again, we just need to have a discussion with who that is. I've worked with various others, but yeah, there is possibilities of potentially taking and extracting that data, but we just really need to have a discussion on what the software is and so on. But I'll touch base with you on that.
Yeah.
And a few other questions in regards to will we be sharing the video? Absolutely. So after this, we'll be sending you a thank you email with all the necessary information, PowerPoint, and obviously the video. So yeah. Without further ado, I'd like to say thanks to the team at HighQA. I know it's early morning for you guys, but yeah, appreciate your time and I hope everybody's found that useful. If you need anything, feel free to contact us at sales@thesempragroup.com. But yeah, more than happy to provide any demonstrations either on site or over Teams in the best manner that you like. But yeah, thanks again for everybody involved in this session.